Okay, so I'm recording now. Okay, so hello everyone. I'm Dave Schwartz, and this is Math 1430, Section 2.6, the derivative. And I'm just going to do this one problem because I don't want to make the video too long, and at the same time, this problem does take at least 5 minutes. Okay, so it's going to be a perfect length. Use the limit definition of derivative, or four-step process, to find f prime of x. So f prime of x, this means the derivative of f, for the function f of x equals x squared minus 2x. So for the solution, I'm going to use the four-step process for finding f prime of x. So strictly speaking, you don't always have to do the four-step process, but it's my recommendation. I think that's the easiest approach. But as long as you're using limits, that's the main thing. So the first step is to find f of x plus h, because this is going to be part of our limit definition. So this means evaluate your given function of f for this input, wherever you see an x. So here's what I like to do. When I see f of x, you can think of this as f of whatever equals, instead of x squared, just leave it blank again, something, whatever squared, minus 2 times that same whatever. So this is like the template. Whenever you want to input a different expression into your function, if you want to evaluate a function for a particular input, wherever you see x's, just leave it blank. And then don't forget the square to match up with that square, minus 2 times that same whatever. So what am I going to put in all of these parentheses? I want to evaluate the function at x plus h. So let's write x plus h everywhere in these parentheses. X plus h, x plus h, x plus h. Got a little Beethoven in the background for your enjoyment. They say classical music increases brain power, so by the end of this video, we will all be Einsteins. All right, let's simplify now. So to simplify x plus h squared, that means you got to go x plus h times x plus h, and then FOIL it all out and simplify. So you can do that later. I'm going to save time and just write what x plus h all squared turns out to be after you FOIL and simplify. I'm going to use the shortcut. You square the first term, keep the sign in the middle, then it's going to be twice the product of the terms. So x times h is xh. Twice that would be 2xh. Then it's always plus the last term squared. So plus h squared. And then let's distribute the minus 2 for minus 2x minus 2h. Notice there are no like terms, So I'm done with step 1 of the four-step process. Step 2 is to find f of x plus h minus f of x. Let's find this difference. So f of x plus h minus f of x. We already did from part 1 f of x plus h. So in place of f of x plus h, I'm going to write what we just got. X squared plus 2xh plus h squared minus 2x minus 2h. So that takes care of the f of x plus h. Checkaroo. Now I got to go minus f of x. So minus, and what is f of x? Well, for us, it's given as x squared minus 2x. Notice this is an expression with two terms. So whenever you have minus f of x, and f of x is more than a single term, you must write minus the expression of f of x. So inside the parentheses, I'm going to write what f of x was given as, x squared minus 2x. And then let's simplify. So rewrite x squared plus 2xh plus h squared minus 2x minus 2h. And then distributing carefully, I get a minus x squared plus 2x. And then look at this, I get some canceling here. The x squared cancels with the minus x squared. The minus 2x cancels with the plus 2x. So you always get canceling with these four steps. So when you go f of x plus h minus f of x, if you're doing it correctly, you'll get some canceling. If you get no canceling, it means you made a mistake. Probably you did a sign error. So don't forget, this minus and a minus gives you the plus 2x. Okay, so let's see what we're left with here. I've got 2xh plus h squared minus 2h. And that's simplified enough. I could pull out an h, I'll do it later though. Step 3. Here is step 3 of the 4-step process. To write this difference quotient, f of x plus h minus f of x all over h, where h is some small number usually. Think of h as a number approaching 0, but not 0 itself. Okay, so what is this difference quotient going to be? Well, I know the whole numerator is what we did in step 2. So the numerator gets replaced by our answer in step 2, our simplified answer. So write 2xh plus h squared minus 2h all over h. What's nice about the 4-step process, by the way, is I don't have to write the word limit until step 4. So it's a little easier this way. You don't have to keep on writing limit, limit, limit. Okay, so before I go to step 4, I notice I can pull out an h from the numerator and cancel it with this h. Remember, this is totally illegal to cancel this h with, say, this h. You cannot do that. It's tempting. But isn't this 2h just a term? Terms are separated by pluses and minuses. I've got 3 terms in the numerator, so you can't cancel part of a term with a factor. So here's what you want to do. Put this in factored form. Pull out an h, because that h goes into everything. It's the GCF. So when I pull out an h, what am I left with the first term? 2x. Plus h times h gives me the h squared, minus just 2, minus 2. And that's all over h. Now I can cancel these factors of h. So this simplifies finally to 2x plus h minus 2. And that's completely simplified. And now for my 4th and final step. Here it is. Write f prime of x equals the limit as h approaches 0 of this difference quotient. And that difference quotient simplifies to simply 2x plus h minus 2. 2x plus h minus 2. If you want, you can put parentheses. That's optional. And because I was able to cancel these h's, this limit will be very easy to evaluate. I just do a direct substitution. I can do a direct substitution because I already canceled out the h's. So when I let h equal 0, this becomes 2x plus 0 minus 2, which just simplifies to 2x minus 2. So when you do the direct substitution, do not write limit again. Just write, for your final answer, 2x minus 2. And that's our final answer. So f prime of x is equal to this limit, and that limit is just equal to 2x minus 2. So one application of derivatives is they'll give you the slope of the tangent line for any x on the graph of f. So for example, if they ask you what's the slope of the tangent line of the graph of f when x is equal to 2, you would just find f prime of 2, for example. So wherever you see x's, you write 2. So f prime of 2, the slope of the tangent line at x equals 2 of our graph of f, would be f prime of 2 equals 2 times 2 minus 2. This is just a quick application of derivatives. 2 times 2 is 4, 4 minus 2 is 2. So that would be the slope of the tangent. Sure enough, if you were to graph the function f and look at the point when x is equal to 2, the slope of that tangent line would be a positive 2. Okay, but this was just bells and whistles that I did. This is the final answer for our problem. Step 4, right there. There's our final answer. F prime of x is equal to 2x minus 2. Notice we did the 4-step process for that. Okay, so I hope that was helpful. And, don't forget to watch the video on WebAssign. This is an important section, so it's good to put in your time. And just to give you a little quick speech here, you can be either a flounder or a salmon in the world of fish. So if you choose to be a flounder, that just means you flounder around and you try to do as little work as possible. But if you're going to be a salmon swimming upstream and working hard, that is going to be the payoff. So be a salmon. Be a salmon. Good night, everyone.